Hello, I'm Tom Olson from the National Weather Service Springfield, Missouri office, and today's Weather Unlocked topic is layers of the atmosphere. First off, the definition of atmosphere is a cloud of gas and suspended solids extending from the Earth's surface out many thousands of miles, becoming increasingly thinner with distance but always held by the Earth's gravitational pull. The atmosphere is made up of layers surrounding the Earth that holds the air we breathe, protects us from outer space, and holds moisture, gases, and tiny particles. In short, the atmosphere is the protective bubble we live in. This protective bubble consists of several gases, with the top four making up 99.998% of all gases. By far the most common, nitrogen, dilutes oxygen and prevents rapid burning at the Earth's surface. Living things need to make proteins. Oxygen is used by all living things and is essential for respiration. It is also necessary for combustion or burning. Argon is used in light bulbs. Plants use carbon dioxide to make oxygen, and also carbon dioxide in clouds, which is water vapor, which is not included in the chart, is also act as a blanket and prevents the escape of heat into outer space. So what are the distinct layers of the atmosphere? The envelope of gas around the Earth changes from the ground up. There's 5 distinct layers. They have been identified using thermal characteristics, chemical composition, movement, and density, and each of these layers are bounded by pauses, where the maximum changes in thermal characteristic, chemical composition, movement, and density occur. The first layer of the atmosphere is the troposphere, from the word tropos, meaning change. The troposphere begins at the Earth's surface and extends up to about 4 to 12 miles high. This is where we live. As the gases in this layer decrease with height, the air becomes thinner. Therefore, the temperature in the troposphere also decreases with height. As you climb higher, the temperature drops from about 62 Fahrenheit to about minus 60 Fahrenheit. Almost all weather occurs in this region. The height of the troposphere varies from the equator to the poles. At the equator, it is around 11 to 12 miles high, and at 50 degrees north and 50 degrees south, it's about 5.5 miles, and at the poles, just under 4 miles high. The transition boundary between the troposphere and the layers above it is called the tropopause. Both the tropopause and the troposphere are known as the lower atmosphere. The second layer of the atmosphere is the stratosphere, meaning the sphere of layers. The stratosphere extends from the tropopause up to about 31 miles above the Earth's surface. This layer holds 19% of the atmospheric gases, but very little water vapor. Temperature increases with height as radiation is increasingly absorbed by oxygen molecules, which leads to the formation of ozone. The temperatures rise from an average of minus 76 Fahrenheit at the tropopause to a maximum of about 5 Fahrenheit at the stratopause due to this absorption of ultraviolet radiation. The increasing temperature also makes it a calm layer with movements of gases slow. The regions of the stratosphere and the mesosphere, along with the stratopause and mesopause, are called the middle atmosphere by scientists. The transition boundary, which separates the troposphere from the mesosphere, is called the stratopause. The third layer of the atmosphere is the mesosphere, from the Greek word meaning mesos, meaning middle. The mesosphere extends from the stratopause to about 53 miles above the Earth. The gases, including the oxygen molecules, continue to become thinner and thinner with height. As such, the effect of warming by ultraviolet radiation also becomes less and less, leading to a decrease in temperature with height. On average, the temperature decreases from around 5 degrees Fahrenheit to as low as minus 184 degrees Fahrenheit at the mesopause. However, the gases in the mesosphere are thick enough to slow down meteorites hurtling into the atmosphere, where they burn up, leaving fiery trails in the night sky. The fourth layer of the atmosphere is the thermosphere, from thermo meaning heat. The thermosphere extends from the mesopause to about 430 miles above the Earth. This layer is known as the upper atmosphere. The gases of the thermosphere are increasingly thinner than in the mesosphere. As such, only higher energy ultraviolet and X-ray radiation from the sun is absorbed. But because of this absorption, the temperatures increase with height and can reach as high as 3,600 degrees Fahrenheit near the top of this layer. However, despite the high temperature, this layer of the atmosphere would still feel very cold to our skin because of the extremely thin air. The total amount of energy from the very few molecules in this layer is not sufficient enough to heat our skin. The fifth and last layer of the atmosphere is the ecosphere, from eco meaning outside. This is the outermost layer of the atmosphere, extends from about 375 miles to 6,200 miles above the Earth. In this layer, atoms and molecules escape into space and satellites orbit the Earth. At the bottom of the exosphere is a transition layer called the thermopause. The exosphere is the very edge of our atmosphere. This layer separates the rest of the atmosphere from outer space. It is about 6,200 miles thick. That's almost as wide as the Earth itself. The exosphere is really, really big. That means that to get to outer space, you have to be really far from Earth. The exosphere has gases like hydrogen and helium, but they are very spread out. There is a lot of empty space in between. There is no air to breathe, and it's very cold. Thank you again for watching the topic on layers of the atmosphere.